Thank you guys so much again for coming to our workshop today, going hands-on with multimodal use cases in Gemini. My name is Katie. I am a developer relations engineer for Vertex AI, and assisting me today will be Lavi. Right over there, he will be TAing. So if you also a developer relations engineer for Vertex AI. So if you have any questions throughout the process, feel free to raise your hand and Lavi can come and assist you. Perfect. So to get us up and running today, we will first be redeeming cloud credits. We have a link for you guys to go to so that you can go ahead and get $5 to run this lab today. If you use the first link up top, that is how you will get access to those credits. And just to note that this link is only live for today. So after today, these credits will no longer be redeemable. But once you have redeemed them through the lab, you will be able to use them for, I believe, a couple months once they're in your account. So I'll give everyone a second to look at that. Just copy the top link right off there. And if everyone wants to navigate, I can kind of walk you through the process of redeeming these cloud credits for the workshop today. So once you go ahead and go to this top link, you should be at a page like this. Is everyone getting there? Awesome. Okay. So you're going to want to go ahead and sign in with Google. So enter your Google account. Okay, so everyone should be here if this is looking good for everybody. So after you've signed in, you're going to want to click right here. Click here to access your credits. That will give you $5. So you're going to go to a page like this. It does ask for your first and last name. So we'll just do that right here. And then once you've entered that, go ahead and click accept and continue at the bottom of the screen. Perfect. And if you're getting any errors at this point, feel free to raise your hand and Lavi can come by and assist. Awesome. And then we're just going to want to hit green continue. And you should get a pop-up saying that the credit has been successfully applied. So I believe you won't see this page since I have redeemed credits with this demo account before, but should everyone be able to go ahead and log into the Cloud Console? Is that where it's prompting everyone? Perfect. So from there, you're going to want to log in and click Create a New Project. You should see at the top. Is everyone seeing that? So you're going to give it an ID that you're going to be able to remember. We will have to enter this into the Colab later. So naming it something like my test project, my demo account would be probably a good example. Awesome. Just kind of a show of hands. Is everyone able to get to that step where we've created a project? Awesome. So from there, you're going to want to make sure that the billing account is linked to the Google credit trial account that should be there from the new credits that have been redeemed. So in that new project, if you go to billing, you should be able to click a link and see that the billing account is linked to the new project you just created. And from the billing page within the Cloud Console, you should be able to go to credits on the left-hand side and see that this $5 has been applied. Again, we appreciate your patience as Lavi's making his way around to help some people out. Okay, so Lavi will continue to make the rounds, but I can go ahead and kind of talk through at least some of the next steps. So from here, once you have your credits applied to your new project you've created and you see that the billing account is enabled to those free credits, you're going to want to go ahead and enter the short link down below, which will take us to the notebook that we'll be running through during the course of the workshop today. For the sake of time, you can also kind of follow along within the notebook itself. It's living on our generative AI Google Cloud repo right now, as I talk through some of the examples just so you can view them. And if we have extra time, we can come and assist with the credits and making sure you're all able to run the code. So once everyone has navigated to the notebook, which should look like this, the people that were able to, is this what you're seeing? Awesome. Okay, so from there, you can pick any runtime that you would like. A lot of people are familiar with running in Colab, but all of the links are down below. You can run in Colab Enterprise, which is the same environment, but from within the Cloud Console itself, or from the other option being Vertex AI Workbench. So whichever one of these platforms is most comfortable to you. I will be showing and demoing it from the Colab out-of-box example. So I'll give you guys a minute to find those links there. And while we're navigating, I can kind of go over some of the different models and the topic of this workshop, which is multimodal AI. So the models we will be focusing on today in this notebook are Gemini 1.5, both the Pro and the Flash model, which were announced in the keynote yesterday. So Gemini 1.5 Pro is a language model from the Gemini family. It introduces a long context window currently of up to 1 million tokens that is able to parse a large amount of information. It is also innately multimodal, meaning that it can process text, images, audio, video, and code. So we'll be covering all of those modalities today within this workshop. 1.5 Flash, which was announced, is optimized for high-frequency tasks to prioritize the model's response time. So when you need to focus on speed, 1.5 Flash will be really great for those situations. And again, you can click on the following links to learn more about these models. So today, as briefly mentioned, we will cover all of the individual modalities, looking through how we can reason across text, PDF, images, voice, code, audio. And we can also consider how we can combine all these modalities within single prompts, and then also look at how this can be applied to a retail business use case in vertical. So to get started, you're going to want to go ahead and install the Vertex AI SDK for Python. If you go ahead and run that cell, it will install everything you need along with some other libraries that will come into play later on, specifically for the code analysis section. So you can see, for the sake of time, I've run these. So it should install all of the requirements just like so. I'll give a minute for everything to get installed. Perfect. And then from there, once that cell has finished running with a little green check mark to the left of it, you're going to want to restart the runtime to be able to use all of these newly installed packages within the Jupyter notebook. So you're going to want to head and run this cell, which will restart. It'll give you a message at the bottom saying that it crashed, and then once it comes back, you'll get a message at the bottom for that as well. And since we are running in native Colab, we have to authenticate our notebook environment. So from here, you're going to need to run this cell, which will create a pop-up to log into your Google account. And from there, you're going to just want to enable the permissions that you will need to be able to run this notebook in Colab. Okay, and once you've authenticated your account, we're going to type in the project ID and the location that we will be running in within Google Cloud. So the project ID is the one that you just created when you redeemed these credits. So my demo account, or whatever you named it, to take note of that, you're going to want to enter that into the project ID box right here. And then once you've entered that in the cell, you're going to want to run this entire code snippet so that we can authenticate your user profile. And from there, we're going to want to import different libraries that we'll be using within the notebook, all from the Vertex AI SDK. Okay, and this next cell is the part where we'll specify the models that we'll be using. So again, we'll be using the Gemini 1.5 models for this notebook. We will instantiate both the 1.5 Pro model and the 1.5 Flash model as articulated by those variables there. So if you run that cell, we can kind of show how we can interchange throughout the two different models in the notebook. We will also be defining some helper functions. Since we will be working with multiple modalities, we want to be able to visualize them in the space. So these functions will help us do that. So now that all of the setup is complete, we will be diving into the individual modalities themselves. So the first, and I think most common one that people perceive, is textual understanding. So within this example, we can see how Gemini 1.5 Pro parses different textual questions and also is able to retain the context of those questions across a series of prompts. So we can see that in this first question, I'm saying, what's the average weather in Mountain View, California in the middle of May? And then once we have that question, we can provide a series of following prompts saying, well, with this weather, which it has the context of from the previous question, provide some different outfit suggestions, both examples for the daytime and the evening. And so once you generate content from this content that we've instantiated here, you can see what Gemini has to say. So it replies with the weather in mid-May in Mountain View, giving the average high, the average low, as well as the sunshine and rainfall. So you can see it's able to reason, even though we didn't specifically ask for any of these parameters. It also provides some outfit suggestions, which we did ask for, but it also goes one step further to give examples and kind of shows the different ways that it's incorporating what it knows and reasoning based on the prompt alone. Another interesting modality that we can input is document summarization. So from here in these examples, we're going to use Gemini 1.5 Pro to process PDF documents. So the example that we will be using in this case will be the research article from Google DeepMind about Gemini 1.5, unlocking the multimodal understanding across this large context window. So you can see that this PDF document is 77 pages long, and we are going to provide it in its entirety to the model to reason across. So from here, we start by asking a basic question. We say, how many tokens can this model process? Which we assume is an answer that can be found in the paper itself. And it does return the answer, saying that the Gemini 1.5 Pro model can process up to at least 10 million tokens, which is outlined in the paper if you go to the article, the link above, and look at the PDF itself. And so now this is great. It can parse out different pieces of information. It can answer direct questions. But 77 pages is a lot, and we don't always have time to read all of that. So the next prompt can be something a little bit more abstract, saying, you're a professional document summarization specialist. So now we've provided a role for the model within the prompt itself, and we're asking it to summarize the entire document. And we can see here that it's able to pull out from all 77 pages different key features and achievements of the model, as well as different evaluation metrics and info on its deployment, which gives a great synopsis of the PDF file in its entirety. And once you run these cells from the notebook yourself, you'll be able to see that they can execute rather quickly for how much information we're providing. So another cool component is being able to understand images and reason across multiple images at once. So from this case, we're going to provide different glasses to the Gemini model. Maybe you're shopping at a store and you want to, get a neutral input about which ones would look best based on your face shape. So in this example, we're asking the model to, which of these glasses do you recommend? I have an oval face. And we're giving 2 different pairs of glasses as shown below right there. And so the way we're structuring this prompt is we're specifying which pair of glasses is which. So glasses 1, followed by the link to that image, glasses 2, followed by the link to that image. And rather than Gemini just giving us a straight answer, we're going to ask it to explain its decision. How did it get there? What's the logic behind recommending one pair over another? And we can see that when we run the cell, it gives some nice feedback. Oval faces are considered the most versatile when it comes to glasses. So it was able to provide some reasoning based on the 2. And it's able to infer, the shapes and reason across each. So it says, well, glasses 1, those are square. Glasses 2, those are round. And based on your face shape, this is kind of what we think, depending on what look you're going for, which again isn't something we explicitly asked, but something that the model is able to infer based on the prompts. All right, and entering another modality here, we are looking at video. So we're seeing the ways in which Gemini can reason across videos of different lengths. So in this first video, an example, we're seeing how Gemini can extract tags throughout a video. So if we click on that link, that is the video input we will be providing to the model in this example with this following prompt. So we're saying, what's shown in this video? Where can I go to see it? And also, what are the top 5 places in the world that look like this? So you can see the way that we combine all these modalities within a prompt and query the model on them. So we're able to display the video that we're seeing. So playing a little bit, this is what we're sending to the model here. And then from that, it's able to say that, this is a beautiful place in Turkey. And it also kind of gives more information about the tourist destination of it and different similar places within the world that could also feature this kind of place as shown in the video. And we are able to confirm that the location is correct with the following link in the notebook as well. So, it's great to kind of show videos and pull out information that's explicitly stated in the video or kind of reasoning across all those different image frames. But we're also able to ask Gemini 1.5 Pro to retrieve extra information beyond the video contents. So the next video we will be supplying is outlined in this link here, if anyone wants to go and check it out. But in this sense, we're asking, we're providing a video of a train line somewhere in the world, and we're saying, what line is this? Where does it go? What are the stations and stops? Which traditionally, if you think about it, might be a very difficult query just to Google based on a video image alone. But from this, we're able to see that Gemini is able to return exactly which train stop this will be, that it is a train line in Canada, and not only that, but it can list all of the stops along the specific train route, which again, you can verify through the link here to fact check Gemini. So being able to reason across videos is a great opportunity in modality, but a very helpful example and one that showcases specifically the long context window of Gemini 1.5 is being able to reason across the entirety of a code base. So for this example, we will be using the Online Boutique, which is a cloud-first microservice demo application that's an e-commerce app that users can browse items, add them to the cart, and purchase them. And this application, as it stands, consists of 11 microservices across multiple languages. So we'll go ahead and run these next couple cells, which will help set up for this process. So the GitHub repository link is right there. We will also define some helper functions for processing the GitHub repository, being how to clone it, how to index it, and how to format it so that we can send it to the model. From there, we will run this next setup cell to create an index and extract the contents of the code base, which are those functions we previously defined. We're also going to want to define a helper function to generate a prompt for code-related questions, which we will use later on. So we're giving some instructions to the model. We're saying the entire code base is provided below. Here's an index of all the files, and then each of the files is concatenated together. So we will be prefacing each prompt with this helper function. So one of the first things we're going to ask it to do is provide a getting started guide to onboard new developers to the codebase. And you can see that the model is able to quickly and concisely generate this onboarding guide through different steps, which we didn't even ask it to do. But it's able to give an overview, pulls in architecture diagrams, summarizes all of the microservices. It tells you how you can set up your developer environment, how to clone the repository, how to run the application, all based on nothing other than the code itself as an input. Another possible query amongst a code base is, finding bugs within the code. We can actually provide the whole code base to the Gemini model and say, find the 3 most severe issues within this code base. And it is able to return an answer. As you can see, it defines the top 3 issues that it sees based on the code alone, being the product catalog reloading bug, and the other following options there that you can read more about. Another interesting question is just asking the model to summarize the code base. And so from here, you can say, we can try out Gemini 1.5 Flash. So we can give it the question, give me a summary of this code base and tell me the top 3 things I can learn from it. And from here, we can see that compared to the previous cell, we structure the prompt the exact same way. We're simply using the multimodal model Flash variable, which we previously defined at the start of this workshop. And it is able to return a summary of the code base with the top 3 learnings being the microservice architecture, the Google Cloud integration, and information on protocol buffers. So to pivot now into audio understanding, We can see how we can provide audio clips and reason across those as well. With the 1 million context window, that equates to, I believe, about 8.4 hours of audio footage alone. So from here, we're going to supply it with a podcast episode based on the upcoming launch of a new Pixel phone, which if you want to run the cell and play the audio, you can at a later time. But what we're going to ask Gemini to do for us is summarize this full 10 minutes of audio. And in less than a minute, it is able to tell us, this is the title of the podcast, here are the chapters, and kind of give titles to each of them. You notice that in this prompt, we're pretty specific. We want really short titles. We want it to be concise. We don't want it to summarize the chapters for us. We just want an overview. And I can specify the format that I want the data returned. In this case, I said, in a numbered list. But if I'd asked the model here to return it in a JSON format, it would be able to do that as well. So you're able to specifically ask the model within the prompt how you want your data to be formatted and returned for your consumption. And lastly, we say, don't make up any information and do not be verbose. So we're able to get concise chapter titles based on the audio input. We're also able to generate an entire transcription, which this is a great use case for Gemini 1.5 Flash. Parsing through a lot of audio is something that needs to be done quickly. You don't need every single word transcribed in this case. You're just looking for an overview. So using this model here would be really helpful. It's able to return it. I believe the last time I ran this in 20 seconds with this model, and it's able to provide everything in the format that we ask for. So we want timestamps, we want speakers denoted as A, B, and so forth. And it's able to do that and provide us an entire transcript of the 10 minutes of audio relatively quickly. So now that we've looked at all the ways that we can reason across individual modalities, we can look at how to expand this even further by combining them. So we've seen a little bit how we're able to provide one type of input with a textual prompt, that's already combining two types of modalities. But what if we want to do more? Within video clips, we're going to have audio attached to them. So we want to be able to reason across not only the images that it's seen within the video clip, but also the audio attached to each individual timestamp. So within this video, we're looking at what people are able to do with their Pixel phone. And so we're prompting it with provide a description of the video and contain any important dialogue. We want to make sure we capture that. So from here, we're able to see that it's able to do just that, taking into account the video, but also the audio that's attached. And so now for the grand finale of all of the modalities, before we jump into some of the use cases, we can see how within a single prompt, we're able to provide images, video, audio, and text, and also reason across them throughout different prompts. So it's able to not only take all of these as input, which traditionally has been a struggle in the field of AI, but also reason across all of them when we ask for information and maintain that context as we continue to ask questions and follow up as examples. So we're able to see here that we're going to provide a video talking about a new feature, and then we're going to supply a screenshot that occurs somewhere in the video. So we're combining the audio, the video, and the image so far with textual prompts and understanding. So we're saying, look through each frame in the video carefully and answer the following questions. Do not make up any information and be very straightforward. So you can go ahead and preface the model with the context that you want it to have when reasoning across these. So we want it to say, when is this moment happening and what's the context of it? And through this entire video clip, which is over 5 minutes, it is able to give us the exact timestamp of when it sees the following frame and give the context behind it and what's happening. Without having watched the video, you're able to get information about individual moments within it. So now kind of jumping into a use case scenario, a great way to showcase the modalities of Gemini is through the retail or e-commerce space. So from here, we can pretend that we're an online retailer in the home improvement area. So we're saying that a customer shows you their living room. For example, this is what it looks like. And just keep in the back of your mind that maybe we're offering these 4 different pieces of art. And eventually, we're going to want some help choosing which one would be the best fit for our room. So first off, the thing that we can do is generate just open recommendations. Without providing any samples, we can directly ask the model, describe this living room, and based on what you see, what would you recommend for me? Which is a great first step for customers when they're looking to revamp their space. So we can see that just asking Gemini to describe the room, it says that it's a minimalistic living room with a focus on natural textures and neutral tones. And it even goes a step further, which we didn't ask it to do, but inferred based on the prompt, and gives us the descriptions of the walls and the flooring, the furniture, and the decor in the space. So now we're saying, okay, you've described the room, you've seen it. How would you recommend a new piece of furniture? And so from there, it says, well, it could really benefit from a large statement piece on the wall. And, we asked for a reason why, so it's able to provide in detail, it's an empty wall, we need to balance it. Here are some suggestions I might have for you. And so the customer can then say, great, I need a piece of wall art, I need something to hang. So from there, maybe they browse the catalog of inventory and they pick out what speaks to them. So we can then, with this prompt, go ahead and provide the room to the model, as well as the 4 pieces that we are trying to decide between. And then we can prompt the model, saying, you're an interior designer. For each piece of wall art, explain whether it would fit. And maybe I want a really clear answer. I want, what does Gemini think I should do here? So you can even ask it to rank the specific items. So just to recap, in this prompt, we are giving it the image of the living room. We are labeling each art piece as 1, 2, 3, and 4. And it goes ahead and gives us an analysis of each piece. It looks at each one. It comments on the appropriateness of the art within the space, as well as the compatibility scores based on the room that we provide. And then we did ask for an overall ranking. So it does at the bottom say, you know what, art 2 is the best, art 4 would not necessarily fit. So if you go back up, you can, art is very subjective, but you can kind of agree that certain pieces would work, and Gemini's reasoning does make sense for the given scenario, which is another way to combine lots of modalities within a single prompt to be more customer-facing as well. All right, and that wraps up the analysis of our multimodal notebook. So thank you guys so much for attending. It was great to walk you through these examples and show how you can use the different modalities and benefits of Gemini to query and parse different information. So thank you, everyone.